Hello? In this lesson, we'll write a script with methods for changing the character's width and height, and program the character to change when passing through the gate. This is what we'll get in the end. The character will change after running through different types of gates. I'd like to elaborate on the character's width. To set it up, we'll need a special shader. A shader is a program that defines how the model is visualized on the screen. We'll need a shader that shifts the model's vertices along the normal to the surface. In Unity, shaders can be created in the Shader Graph window. It's a node editor that you can use to create your own shaders without code. A node means it contains various blocks that you connect to each other. We won't learn how to create shaders in this lesson, because this topic, although very interesting, is too big, so I suggest you download the shader file under the video and move it to your project. I attached shaders under the video. Let's drag them to the project. Here is the shaders folder. Choose it and drag it to the assets folder. It contains 2 shaders. Now we'll need the one that makes the character wider. I also created a shader for the ground. We're going to see how it works shortly. The shaders were created in the Shader Graph editor. You can Google it and try to get to grips with it yourself. It's quite interesting, really. You can use it to create unique visual things. However, now we'll use ready-made shaders. It's quite common to find a ready-made shader and download it from the internet to use in your project. Here's the shader. Now you need to create a material based on it. For example, like this. Right-click on it and choose Create Material. I'll call it Push. Now select it and drag it to the object. This is what it looks like on the object. Here we can see the same settings that we used in the standard shader. There are fewer of them, though. Only the basic ones are left. You can add flashes or make the character brighter and make it gleam. But the key parameter here is push value. This is how it works. It makes the character bigger by pushing its vertices away along the normal. You can see how this shader works. If you double-click on it, the shader editor window opens. It's Shader Graph. Here you can see nodes and blocks that connect to each other to make the push parameter change the position of the model. Okay, great. We've configured this shader. I also attached a shader with the road. Let's also create a new material based on it. Create Material. I'll call it Ground. There's a problem with our road. If you change the size of the road, for example, if you decide to make it smaller as you develop the game, its texture flattens and looks completely different. Like this. But thanks to this shader, you can change the size of the object without deforming its structure, because the position of the texture is linked to the coordinates. I added the material to the road. Now we need to place the texture here. Click Select and find the texture with stripes among all the textures in our project. There's still a little more to set up. You only have to configure these parameters once. It also has the color setting. I want to make it a bit bluer. Now when the road changes, the texture doesn't deform. I think it'll be great for our game. Now let's move on to the player, because we wanted to talk about the player deformation. I'll create a new script and call it Player Modifier. I'll assign the script to the player here. In this script, we need to make several fields. First, the width and height. I made them integers. These parameters will change when the character passes through the gate. If it passes through the gate with +50 written on it, 50 will be added to its width. We'll also need to link this width to the push parameter eventually. The material has the push parameter push, and if you look at it, you can see it changes within a very small range. This defines how much bigger the character gets in meters. If the number is 50, it'll block out the whole world with its body. So before assigning this number, we'll multiply it by a small coefficient. To do this, I created two more fields: the width multiplier and the height multiplier. This multiplier will render this integer value into the one we are going to use in practice. One more thing. We won't need start here. Now let's create methods that will change the value. Public void add width and public void add height. To add height, let these methods take a value. They'll be called when the character runs through the gate. The value is the number written on the gate. It will simply be added to the width. And here it will be added to the height. In this method, we also want to change the properties of the material. To do this, we need a link to the renderer component. In it, we refer to the material on this object. Now I want to change this property called push value. The push value has a float type. It's a decimal number, so we'll use the setFloat method. We need this method if we want to change a property of the material. setFloat. Now specify the name of the property in parentheses. It should be written in quotation marks, first an underscore and then the property name. Underscore push value. Right. It should be written exactly like this. The name is the same as here, but you need to add an underscore in front of it. This is how this particular method and shader names work. Now let's set the value we want to assign here. I'll take the width and multiply it by the width multiplier. This one here, and we'll get a smaller value. This is basically it. The width will change, but to test it now, we'll need to program the gate and make the character run through it. This will take a long time. Let's write a test piece in the update as an example. If we press a button like W, get key down, keycode.w, then we'll call the addWidth method and add 20 to the character's width. Similarly, you test increasing height. In this case, press H on the keyboard and call the addHeight method. We'll delete this piece when we have all the gates ready, but it's convenient for testing. Let's go to Unity. We need to add our player's renderer here. It's in the body object. Click play. I'm pressing W. He's expanding widthwise. I can also press H. Nothing changes right now, of course, but the number here is increasing, which is good. Let's just work on the height. How do we do this? There are a lot of options. The boring way, which also isn't very pretty, is simply stretching the character up. But this doesn't look good. Let's do it this way. If you expand the hierarchy of the character's bones, you can see it has several backbones here. Let's take these two. Spine 2 and Spine 3. If you stretch the Spine 3 bone up like this, the height increases in a pretty interesting way. The height in our script will affect this distance. Or rather, the distance between Spine 2 and Spine 3. While we're on the topic of them now, let's assign icons to them. These circles, for example, to see them clearly. We'll be changing the distance between these 2 points in the script. To do this, we need links to these 2 objects in our player modifier script. So let's add new fields here. The type is transform. I'll call the first field underscore top spine. And the second one underscore bottom spine. Lower back. The idea here is to take the top spine and assign it a position. This position will be equal to the position of the bottom spine plus a vector. Vector 3. We need to stretch it up. It's the y-axis. I'll lift it 2 meters. This should be underscore bottom spine dot position, of course. Let's see how this looks. Let's start the game. Of course, I made a common mistake and forgot to add links to the objects in the inspector. If something doesn't work, look here in the console. What you'll often see here is this error: the variable has not been assigned. You'll see this error all the time if you forget to assign variables. If something doesn't work, the first thing you should do is check the console and read what it says. If you don't speak English, translate it in an online translator, because it usually explains your error. Great. The position of the upper point is 2 meters higher than the position of the lower point, just as we wrote in the script. But I don't want it to be 2 meters, I want it to be a value that depends on the height. Let's calculate this value. What do we have to replace 2 with? I'm going to create a new variable here to make it neater and avoid long calculations in the brackets. Let's call this value offset y and multiply the height parameter by height multiplier. The more the height, the higher the offset. Next, we replace the 2 with this offset. I guess it'll look funny now because the character will be completely flattened when the height is 0. Now he's tiny. That's why we also need to add the initial offset that these 2 bones had. Let's not sweat it. I just know it's about 17 centimeters. So just add 0.17 to this f. That's it. It'll be working right in the update. We can already test what will happen if you press the H button. It grows like this. Now we need to make it all work when the character passes through the gate. But don't forget the most important thing. I almost forgot about it. According to our gameplay, our character grows for a reason: to get to coins that are located high above. And to collect coins, it uses its collider. So when the character grows, its collider should also grow like this. Therefore, we need this parameter, the collider height at the y-axis, to change in the script, too. For this, I'll add the link to the collider to player modifier. Or, to be more precise, the link to its transform component. Let's find underscore collider transform. How do we calculate its value? By trial and error, I think. Underscore collider transform dot local scale equals. The value at the x and z axis is 1. As for the y-axis, let's think. I remember the initial height of our character is 1 meter 84 centimeters. Then we add to this height an additional amount calculated here. So it'll be 184 centimeters plus height multiplied by height multiplier. Careful now. Of course, I forgot to add the link to the collider's transform again. We press H and see that the collider touches the top of the character's head, so now it will be able to collect coins high above without any problems. There, it has collected a coin with its head. The last thing we need to do is the key point of our game. We need the width and height methods to be called when passing through the gate. We need to change the gate a little for this. I'll go to the gate prefab. You can also click this arrow here. Then you will sort of fall down to the prefab. To register that the character passed through the gate, we'll need a trigger, as we already did there with a coin. I'll add the collider component right here, in the gate object. We need the box collider. Now let's set up the collider. Click here and configure the collider so that it occupies this area. Like this. I'll make it thinner. I hold Alt so that it shrinks relative to its center. It's better to get rid of anything that is not related to the gameplay. For example, we don't need these two colliders on the gate, so I'll remove the colliders from these boxes. This one and that one. Our character can't crash into the gate, it'll just run through them, but it's important for us to register the fact. Check the is trigger box, and now let's edit our gate script. Add the onTriggerEnter method here. Now we have to make sure the object that passed through the gate is the player. If it's the player modifier component here will be able to refer to it and change its width and height. How do we do it? Look, the onTriggerEnter method has the other variable. It will store the collider that got into this trigger. We can learn something about this object. This is what we'll do. If other.attachRigidBody.getComponentPlayerModifier. Using this string, we make sure that the object that is now in the trigger is the one that has the player modifier component. Please note I wrote attachRigidBody here. This means we refer to the collider that entered the trigger and check what rigid body it belongs to. Our player has the collider component, but this collider is inside the player's rigid body. This way, we can refer to the upper level to see which rigid body this collider belongs to. If this is the object that has the player modifier component, it's okay. I'll also need to call a method from it something like this. Add height. And set a value there. To avoid similar strings and using the get component several times, we can save the component that we received into a variable. This is what I often do. Create the player modifier variable and save to it the component that we have or haven't found on this object. Then we check whether the component is there, like this, equals 0. And if it is, if this component has been found, then a value will be assigned to this variable. If there's no such component on the object, the value will be null, and this if won't work. The exclamation mark with the equals sign means it's not equal. We can actually make this string even shorter. You can just remove this part. This way, we check if there's anything stored in this variable. That's it. This is how you can understand what got into the trigger. Now let's get more specific. Let's say the player got into the trigger. We need to check the type of this gate. if its deformation type is width. If it changes the width, then we need to call the width change method from this player. It's addWidth. And what we need to pass to the method is not 10 but the value of this gate. If the deformation type is not width, let's put it like this. Else if _deformation type equals deformation type height, then we call the addHeight method from the player modifier and pass the value to it in the same way. This is basically all the gates have to do. Make sure again that this box collider has a trigger component and that it is located exactly at the top level of the gates hierarchy. Now let's see how it works. We could see that it had become a little bigger. Let's copy more gates to get something more interesting. I think it's the most boring part of our development. Change the type. Let it be 100. Let's check shrinking too. Here the height will decrease by 25. We created only the addHeight and addWidth methods, but if you pass negative values to them, the height and width will decrease. It's obviously plumped up, right? Now it's grown. Now it's a bit thinner. Everything works fine. As a result, we got something that resembles a real game. You can even control the character. In the conclusions, you can see the key points that you should learn from this lesson. But if something didn't work, or there's something you don't understand, I recommend watching the video again and repeating everything I did.